Hello everyone, I welcome you all to this class. Today we want to solve more examples under this topic, polar form of a complex number. So in this example, we want to find the polar form of 1 plus I. So let's start the solution. I told you in our previous video that the first step is to get the principal argument, axis. And the principal argument, the formula you are going to use depends on what? The sign of the real part and the imaginary part. Now, if the real part is positive, the real part is 1. The one that does not go with I is the real part. So here, 1 does not go with I, right? That's the real part. So the real part is 1 and it's positive, right? So the formula you are going to use simply tan inverse of y over x. So that will give you the principal argument. So shortly, this will be tan inverse of y is the imaginary part. Imaginary part, coefficient of I. What's the coefficient of I? 1. X is the real part. What's the real part? 1. So this will be tan inverse of 1 over 1, 1. Tan inverse of 1, 45 degrees. 45 degrees is tan inverse of 1. 45 degrees. But our angle must be in radian. I told you in our previous video, our angle must be radian. So quickly you convert 45 degrees to radian by multiplying it by pi over 180 degrees. So that 9 divided by 6, I have 4. So my answer will be what? Pi over 4. Pi over 4. That's the principal argument. Next one, get what? Get the modulus of z. Modulus of z is given by square root of, I told you in our previous video, right? The modulus of z what is given by the square root of what? Real part squared plus what? Imaginary part squared. What did I say? Real part squared plus imaginary part squared. What's the real part here? 1. 1 squared plus, what's the imaginary part here? 1. 1 squared. 1 squared is 1 plus 1 squared is 1. 1 plus 1, 2. So I have square root of 2. So now your complex number z can be expressed in polar form. It's now ready to be expressed in polar form. So the polar form of z is given by modulus of z into cosine theta plus I sine theta, where theta is what? The principal argument, right? So what's the modulus of z? Square root of 2 into cosine. What is the principal argument? Pi over 4 is the principal argument plus I sine pi over 4. So with this, we have expressed this complex number in what? In polar form. So quickly, we can solve more examples, right? So now let's find the polar form of this complex number, 1 minus I. Let's see what will be the polar form of this very complex number. First of all, find the argument, right? Argument of z equals, now I told you in our previous video when I introduced the topic argument of a complex number, I gave a formula that if the real part is positive, the formula for the principal argument is what? Simply tan inverse of what? Y over x. So this will be tan inverse of, our real part is positive, right? That's why I'm using this formula. So y is what? The coefficient of I, the imaginary part. What is the coefficient of I here? Negative 1 over x is what? Positive 1. And this will be tan inverse of minus 1. You can bring out the minus out, right? That this will be minus tan inverse of 1. But we have just finished solving that one. Tan inverse of 1 is what gave us pi over 4 in radian, right? And we have minus here. Since we have minus here, so we have negative pi over 4. So negative pi over 4 is the principal argument of this complex number. Then what will be the modulus? Modulus is just square root of real part squared, that's 1 squared, plus imaginary part squared. So we'll be having minus 1 squared. Right? That's square root of 1 squared is 1 plus negative 1 all squared will be still 1. 1 plus 1, 2. So that's square root of 2. This formula still holds. This is the polar form of complex number, right? Now, what is the modulus of 0? I've gotten in square root of 2. Then what is now the one we have to change is this. What is our theta? The principal argument, negative pi over 4, right? So we're having cosine negative pi over 4 plus I sine negative pi over 4. So this is now what we are going to have. But I told you in our previous video that cosine of negative angle is same thing as cosine of the positive angle. So this will be cosine of pi over 4. Then here we'll have minus, right? Sine of negative angle is what? Negative sine of the positive angle. So I'm going to bring out this negative out of sine. So when I bring it out, it changes plus to negative. Then I have I sine pi over 4. So this is the polar form of this complex number. Thank you so much for being part of this video. See you next time.